So welcome to the chemistry side of biology. And I understand people often look at biology and say, well, why do I need to understand chemistry in order to talk about biology? All living things are made up of the basic elements that exist on this planet. So if we can get a little bit of a handle on basic chemistry and understand how elements work and why they stick together the way they do, then it helps us understand living things. Especially, the important side of it is when living things get out of balance, they get out of that homeostasis we talked about in the first lecture, often it's because of an imbalance in certain elements. Are you not getting enough iron in your diet? Are you getting too much sodium? Are you not having these molecular bonds form correctly? And is that leading to health problems? We can look at the influx of a simple element like nitrogen into aquatic ecosystems and see how it can destroy an entire ecosystem simply because one element increased in abundance. So we're going to touch on chemistry a little bit. We're not getting crazy in-depth detail like you would in a chemistry course. I keep it very general, and again the goal is to look at chemistry in an application sense. Okay, so first thing we want to look at with basic chemistry here is, what are elements? We talk about these things called elements. Hopefully everybody's heard of the periodic table of elements. Elements are the basic unit of all living organisms. Non-living organisms, or not organisms, but non-living entities, let's call it that, non-living as well. Okay, so elements are these basic structural components. Now the periodic table of elements has, this one here has 110 elements listed. There are 92 naturally occurring elements known to science. Fascinating thing is we're finding new ones. There's new elements being added to the periodic table. Doesn't happen often, but there have been a few new ones discovered. Now the good news for us in this course, we're not worried about 110. We're not worried about 92 naturally occurring ones. We're going to dial it all the way down to 6. That's it. I only want you guys to worry about 6 out of 110. Okay? Keep it simple. The 6 we're going to focus on are going to be the 6 listed up at the top here. CHONPS. That stands for carbon, hydrogen, carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Okay, so those are the 6 we want to focus on. So the goal would be, when you look at a periodic table, you go, okay, here's carbon, here's hydrogen, here's oxygen, nitrogen, phosphorus, and sulfur, those 6. Now we are going to talk about some others. We'll talk about things like sodium. Let's give sodium a little star there. We'll talk about things like potassium, calcium. We may talk about a few others. You got iron over here when we talk about blood and oxygen and hemoglobin, things like that. But really, those are the main ones. Let's throw in chlorine too, because that's that combined with other elements produce certain products that we need. So again, we want to just really focus on those 6 that I highlighted, and occasionally a scattering of a few others. But don't worry about the ones down here. We're not touching any of these elements down here with what we're going to do in this course. That's beyond what we need for basic biology. Okay, so the thing we want to look at here is, here's our learning outcome, number 3. Describe basic atomic structure and the major bond types that atoms form. This is the core of this entire lecture. Okay, so you're going to get hit with this again and again and again and again. So make sure you guys get it. So what we're going to look at here when we talk about elements are made up of these little things we call atoms. So here's our atom over here, this little guy. over on this side. This is that little atomic structure over here making up the atom. Now, elements are made up of these things. Now, an atom itself is going to be made up of three different components. Atoms are made up of things called protons, things called neutrons, and things called electrons. Okay? Protons, neutrons, electrons. So when we go back to our diagram, here's our protons, here's our neutrons, and here's the electrons. Now notice the position. Protons and neutrons are clustered in the center here. And the color, the little red and the blue balls, are just used to help visually distinguish what protons and neutrons would look like and where they would be. The electrons, they use green. Again, it's just to give us a reference point. They don't actually have color. So this is all part of the atomic theory. So protons and neutrons are clustered in the center of your atom, and then the electrons go in these little things out here we call orbitals or valence shells, and we'll be talking about those in a bit here. Okay, so that's the basic structure of an atom. Atoms make up things we call elements. Now when we look at the periodic table of elements, it's going to give us specific information. The information we find listed is called the atomic mass and the atomic number. So there's our atomic mass and there's our atomic number. Those two pieces of information are listed in association with the atomic symbol. The atomic symbol just represents the particular element. C for carbon, O for oxygen, H for hydrogen, N for nitrogen, phosphorus and sulfur, so on. Okay, so when we look at this, this information is essential to figuring out this structure. What should it look like? How many protons, how many neutrons, and how many electrons? Okay, now the atomic mass, that's always going to be the bigger number. The bigger number, the atomic mass, is going to tell us the number of protons plus the number of neutrons that are found in your given element. Okay, so atomic mass is a combination of protons and neutrons. So in the case of carbon, protons and neutrons equals 12. Now, what we really want to know is how many protons versus how many neutrons. That's where the atomic number comes into the picture. The atomic number is the number of protons. Okay? So in this case, carbon 6 means there are 6 protons. Now I'll let you guys do some quick math. If you got 6 protons and an atomic mass of 12, how many neutrons should we be looking at here? Make sure you can do this with any element. Doesn't matter if it's an element you're familiar with or an element you're not familiar with. You should be able to figure these numbers out. So if our atomic mass is 12, and we know based upon the atomic number there are 6 protons, then that tells us the number of neutrons has to equal 6 as well. 6 plus 6 gives us our 12. Let me move this down, make it look, give us more space here. Okay? So get comfortable with determining the number of protons and number of neutrons in a given element. Okay, I don't care what the element is, you need to be able to determine that. So protons, neutrons combined equal your atomic mass. The atomic number is just your number of protons. Do the subtraction. 12 minus 6 tells you the number of neutrons. Now you have 6 neutrons in that given element. The third key piece to figure out are the electrons. So keep in mind, protons and neutrons are clustered in the center. Electrons are going to be up here in these rings or shells. I'll show you those in a second. Sometimes they're called valence rings or orbitals. But that number is always going to equal the number of protons. So every proton will be balanced by an electron. So if your element has six protons, you're going to have 6 electrons. Protons equal electrons. Okay? Alright, the other thing we want to keep in mind, protons, when we talk about energy, are positive. Protons carry a positive electrical charge. Neutrons are neutral, meaning they don't have an electrical charge. And electrons are negative, meaning they carry a negative electrical charge. So you got protons positive, neutrons neutral, electrons negative. So this is why we look at these two balancing each other out. For every positive proton, you want an equal number of negative electrons to balance them out, to keep your element balanced. If you remove an electron, all of a sudden things get off balance. If you add an electron, things get off balance. This creates imbalance, throws it out of homeostasis at the electron level, or the elemental level, due to the electron issue. So we're going to look at this as we go further into chemistry. That's what explains and helps us understand why bonds form the way they form, is because of the number of electrons associated with a given element. Okay, so this, again, this version of carbon, atomic mass of 12, atomic number of 6 protons, because the combination is 12, that means we have to have 6 neutrons. Now, sometimes we see elements come in different forms. These are called isotopes. The isotopes, basically a different form of the exact same element. The isotopes will differ in the number of neutrons. Okay, so let's go back and do the math again. Let me set up a text box. So if you have an atomic mass of 12 for the first one, and an atomic number of 6, here, that's going to equal 6 neutrons. Now if we go down here, atomic mass of 13 minus 6 protons, this will equal 7 neutrons. If we come down here, atomic mass of 14 minus 6 protons equals 8 neutrons. Okay, so this is how it's going to work with the atomic mass. The atomic number doesn't change. It's always 6 for carbon. But what changes is the number of neutrons as we go through each version or isotope of carbon. So different elements have different isotopes. It varies based upon the given element. All right, so I just want to make sure I emphasize that. Now, as we look at these elements, as we look at the basic configuration, keep in mind, protons and neutrons are found in the center of the element. Sometimes this is called the nucleus of the element. The electrons are found in the orbital shells, these little rings drawn out here. There's different numbers of rings. Generally, there are 3, say at most, 3 orbital shells or rings associated with a given element. The number of electrons floating around in the orbital shells is what leads to bond formation. So why do you have 2 hydrogens sticking to 1 oxygen to make water? So H2O. Why do we have carbon, CO2? Why do we have H2 as a gas, and so forth and so forth? It's all due to the number of electrons.